Hi, this is Nisha from IT-Learn team. Welcome to Big Data Hadoop uh, Day-02 demo session. We will just give it 2 to 3 minutes more team and we will start the session at 7:40 p.m. Pacific. We will just wait for a few more attendees to join in and we will begin the session. Okay? Thank you.
Sure. Hi everybody, this is Srinivasa Thirunagari. Uh, Today I am going to take a demo class on Big Data and Hadoop. Let me introduce myself. I am Srinivasa Thirunagari and I have a total of 34 plus years of experience in the IT industry. And right now I'm a freelancer since 2012. I am also a corporate trainer. My clients are Oracle and Microsoft and other major clients. Bank of America, etc. And I have expertise in big data, Hadoop, Python, Core Java, SQL, PL/SQL, MySQL. I'm a frequent blogger and present various. I conduct workshops on big data and Hadoop and Python at various premier organizations such as Indian Institute of Science. So this is all about myself and. Today we'll see what is big data and what is data first of all, and I will explain the challenges in the big data and how we can resolve these challenges using Hadoop. Hadoop is basically a framework. It's a sort of a operating system. It is being installed on the top of Linux machine, and we'll see what it is, how we can resolve these issues related to the big data. First of all, let me define what is big data and what is data. First of all, let us define what is data. Then probably we can define what is big data. So Oxford Dictionary defines data as the quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media. In simple terms, data is nothing but raw facts. They are nothing but raw facts, which I will, give me a moment. I will, say if I write some few numbers, say 56, 78, then 89, 28, 66. Suppose if I write these numbers, they do not convey any meaning. But if I ask a question, what are these numbers representing? The answer is that they say they are the marks obtained by a student in 5 subjects. Then we have some meaning for these data. So basically, uh, data is nothing but raw facts. Okay, similar to it is a raw material. I can say you process the raw material, you get the information, a meaningful information, which can be used to decision making. Okay. So this is the definition given by the Oxford Dictionary. And what is big data? So big data is also data, but with a huge size. Big data is a term used to describe collection of data that is huge in size and yet growing exponentially with time. So data is growing along with the time. As the time progresses, data is also expanding, growing, and it is growing exponentially. So this data cannot be stored on a single machine and cannot be processed using regular servers. Okay, so then we call it as a big data. In short, such a data is so large and complex that none of the traditional data management tools, such as RDBMS, are able to store it or process it efficiently. Then we can call that as big data. So this diagram, look at this diagram. So the person, it is big data and it is growing exponentially uh, along with the time. As the time progresses, data is also increasing. Examples of big data, say New York Stock Exchange, it generates about 1 terabyte of new data per day. Okay, such a huge data it is generating, and the challenge is to store the data and process it in order to take a better decisions. And next example is like say for example take Facebook. Approximately 500 plus terabytes of new data gets ingested into the databases of social media such as Facebook every day. Every day, the 500 plus terabytes of data is being ingested into the system. Such a huge data, and it is growing exponentially every day. And another example is a single jet engine can generate 10 plus terabytes of data in 30 minutes of flight time. So you have so many flights, thousands of flights per day. Generation of data reaches up to many petabytes. So these terabytes and petabytes are the units of measurement of data. Categories of big data. Big data could be found in three forms. One is structured data, where you define it is well defined and well organized. That will be called as structured data. And unstructured data is like movie clips or video clips, audio files, audio. Then we have messages, text files, pictures, etc. They are unstructured. So the data size of one item is different from another data item. You take movie clips, it takes some gigabytes of memory, and pictures take around some megabytes of memory. So it is unstructured, data is unstructured. And then another type of form is semi-structured. Some data is structured and some data is unstructured. So let us see structured data, how it looks like. Categories of big data, structured data, and any data that can be stored, accessed, and processed in the form of a fixed format is known as structured data. So in the structured data, the data is being stored, accessed, and processed in a format, in a specific format, then that we can call it as structured data. Over the period of time, talent in computer science have achieved greater success in developing techniques for working with such kind of data. So, however, nowadays we are forcing issues when size of such data grows to a huge extent. So the data can be stored on machines, but it is growing exponentially. So the single machine is not sufficient to store the entire data. So we have clusters of machines and where you can store the data and process it. Typical sizes are being in the range of multiple zettabytes. How it is? The data is in the range of multiple zettabytes. What is zettabyte? We'll see. 10 to the power of 21 bytes equal to 1 zettabyte or 1 billion terabytes forms a zettabyte. So basically this is the unit of measure of data. Okay. So looking at these figures, one can easily understand why the name big data is given and imagine the challenges involved in its storage and processing. So the challenges involved are storing the data. Once you store it, you have to process the data. Why you process the data? In order to take you derive some meaningful information when you process the data, and that meaningful information can be used for decision making for organizations. They can take a better decision based upon the information they derive from the data. So the challenges are to how to store such a huge volume of data, and data is growing exponentially as the time progresses. So we'll see. Let us take example of structured data. Data stored in a relational database management system is one example of structured data. So we have RDBMS or relational database management system such as Oracle and DB2 from IBM, and then SQL Server from Microsoft, Informix, Sybase, etc. These are the examples of database servers or relational database management systems. Okay, where you process structured data, you store the structured data, process it, analyze it, and you know, if you want more, you can modify the existing data. So let us take an example. An employee table in a database is an example of structured data. Employee consists of first name, last name, then salary, department ID, department name which he belongs to, and his manager name or manager ID, excuse me, and job ID. We call it as designation or job ID, etc. So these are the attributes of an employee. In other words, these attributes are nothing but columns or fields. Okay. So look at this as an example. So we have every employee will have an ID. We call it as employee ID. In this example, the employee ID is 4-digit number. So you can configure it when you create the table. Table is a place where you store the data. Okay. So when you define the table, you define these columns: employee ID, employee name, gender, department, salary in lakhs. Here it is shown as a heading, but this heading is nothing but column names in the table. So the data of employee ID goes to in this column, employee ID, and the name goes to this column in this column, employee name. Like that, you can store the data. So this is a row actually. This is the first row and this is the second row. This is the third row. Like that, we have rows here, and every row represents pertaining to one employee information. Okay. Here, if you observe this, employee ID is 4-digit number, and employee name could be 30 characters in length or 50 characters in length. You define when you define the table. Okay. So the data is structured here and it is finite. The size of the data is finite. It is not huge. It's a small example. Any data with unknown form of the structure is known as unstructured data. So we do not know what is the format of the data. It could be a video clip, or it could be an audio file, it could be a regular file, a text file, or a graphics file, or it could be a picture, or it could be a message, something like that. In addition to the size being huge, unstructured data poses multiple challenges in terms of its processing for deriving value out of it. So we have data that is unstructured. The challenge here is how to process this unstructured data to derive the meaningful information. So we derive the meaningful information in order to take a better decision that will be useful to the organizations. So in unstructured data format, so we have challenges. First of all, how to store the data, okay, and how to process this data, okay. There is a challenge here. Typical example of unstructured data is a heterogeneous data source containing a combination of simple text files and images and videos, etc. Nowadays, organizations have wealth of data available with them, but unfortunately, they don't know how to derive value out of it. Since this data is in its raw format or unstructured format. Because of this reason, they have tons of data. The organizations have tons of information, tons of data, but they don't know how to derive a meaningful information out of this data, which is in the form unstructured format. Say, for example, the example of unstructured data, say output returned by Google search. Say, for example, you search in the Google like Hadoop Bigdata, you search for that, you will get all this information. So you have YouTube and PDF files, PDF information. So you have different kinds of data that is on your, it is displayed on your monitor. Okay. So in this example, around so many pages have been returned in 37 seconds. So the whole world is uh, curious about how the data is being processed when you search on Google. Then they started asking Google, what is the secret behind this? How you could get the data by scanning so many websites within a fraction of a second. So within 37 seconds, this much amount of pages have been displayed. So how is it possible? So it is a trade secret. So Google did not reveal that. And in 2004, they published a white paper, and they in that white paper they mentioned the technique what how they process the data. It is MapReduce technique. So based upon that, a person by name Doug Cutting is now in Yahoo, and he started designing one thing, and initially it is called as Nudge, and finally then it is known as Hadoop. Okay. So based upon that concept, he designed this framework, Hadoop framework. So Hadoop is a framework where they have tools to process the data. So for databases, we have NoSQL or Hive or HBase, etc. And for programming, we have tools like MapReduce technique using Java, and PigLatin is a tool where you process the data, regular files, and Spark is there, is a very popular one. Like that, you have so many tools, and we call it as Hadoop ecosystem. We will see that in a short while. And semi-structured data can contain both the forms of data. It is structured data as well as unstructured data. So we can see semi-structured data as a structured data in the form, but it is not defined with a table definition in relational database management system. Any questions here? So examples of semi-structured data is data represented in XML file. So a personal data stored in XML file looks like this. So name, Prashant, uh, gender, male, age, 35, etc. So this is one record. So the data is represented in the form of, this is a format of XML file, and it is structured as well as unstructured, both. Okay. This is an example of semi-structured data. So now let us see what are the characteristics of big data. So it is huge in size. So volume is one characteristic of big data, and variety of data is there. You have heterogeneous data, and then third one is velocity, the speed with which the data is entering into the system or ingested into the system. So that is velocity is also one of the characteristic of big data. And variability. Variability is different kinds of data like video clips, audio clips, and text files or PDF documents, etc. Variability and then value. Say what value you derive from the data. That is another characteristic of big data. So we call it as 5 V's: value, variety, velocity, variability, and value. These are all characteristic of big data. So let us see what is volume. The name big data itself is related to size, which is enormous or huge. Size of data plays very crucial role in determining value out of data. Also, whether a particular data can actually be considered as a big data or not is dependent upon volume of data. Hence, volume is one characteristic which needs to be considered while dealing with big data. Next, we have variety. So the next aspect of big data is its variety. Variety refers to heterogeneous sources and the nature of data, both structured and unstructured. During earlier days, spreadsheets and databases were the only sources of data considered by most of the applications. We have Excel. Excel spreadsheet is a very popular one, and databases such as Oracle, DB2, which is from IBM, and Informix, Sybase, and SQL Server. These are the sources of data are considered by the most of the applications. So most of the applications have been designed using these servers, Oracle or Informix or DB2 or SQL Server. So the common language, we have to access these database servers. We have a language, we need a language that is known as SQL or SQL, structured query language. So which is common for all these servers. Then variety. The next aspect of big data is its variety. Nowadays, the data is in the form of emails, photos, and videos, and monitoring devices, PDFs, audios, etc. is also being considered in the analysis of applications. This variety of unstructured data poses certain issues for storage, mining, and analyzing the data. Velocity. The next characteristic of big data is velocity. The term velocity refers to the speed of generation of data, with what speed the data is generated and ingested into the system. How fast the data is generated and processed to meet the demands determines real potential in the data. Velocity, uh, big data velocity deals with the speed at which data flows in from sources like business processes, application logs, and networks and social media sites, and sensors, mobile devices, etc. And the flow of data is massive and it is streaming or continuous. Variability. This refers to the inconsistency which can be shown by the data at times, thus hampering the process of being able to handle and manage data effectively. So variability is referred to the like we have inconsistency in data. Okay, ability to process big data brings in multiple benefits, such as businesses can utilize outside intelligence while taking decisions, improve customer services, early identification of risk to the product or services, if any, better operational efficiency, and these are some of the benefits of big data processing. So, in order to process the big data, we need an environment. We call it as Ha- Hadoop. Okay, Hadoop is nothing but a framework wherein you have tools to process the data. So we have file system. In Hadoop, we have file system and we call it as Hadoop distributed file system, YARN. YARN is like yet another resource negotiator, and MapReduce. MapReduce programs are designed using Java. So the prerequisite for Hadoop and big data is Java. And if you are not familiar or if you are not good at Java, then PigLatin is the language or a tool to process the data which is in the form of files. So let us see one by one Hadoop file system. HDFS stands for Hadoop Distributed File System. It is the world's most reliable storage system. And it is a file system of Hadoop. It is designed for storing very large files running on a cluster of commodity hardware. Commodity hardware means inexpensive hardware, cheap hardware we call it as. And we have cluster of machines where the files are being stored. And it is designed on principles of storage of less number of large files rather than the huge number of small files. So we store a less number of large files in the system in the HDFS rather than huge number of small files. It also provides fault-tolerant storage layer for Hadoop and its other components. That means when you run the application that has been designed on Hadoop and you are running the application, we never know that it will run successfully. So in case of any faults, in case of any errors, still the system will not stop or terminate due to some error. The system will continue to process the data that we call as fault tolerant. Okay? It is possible on Hadoop. And this is achieved with the help of replication of data. Okay? You replicate the data. So we have cluster of machines and the data is being replicated on different machines. Even one machine fails and the system will go to the next machine and get the data and process it. It stores data reliably even in the case of hardware failure. It provides high throughput access to application data by providing the data access in parallel. This is the mechanism. And we have nodes actually. HDFS is in the form of nodes. Nodes are machines, and we have two types of nodes, and it works in the master slave fashion. It also has two types of nodes that work in the same manner. One is name node, another is data node in the cluster. It looks like this. We have nodes, we have master node. Master node consists of the data about data, data about information about slave nodes, which data is being stored on which machine, etc. All those information is stored in the master node. And also, you can schedule the job and the job execution is taken care by the master nodes. And data is stored in the slave nodes. So let us see what is name node. Name node regulates file access to the clients. and it maintains and manages the slave nodes and assign tasks to them. Name node executes file system namespace operations such as opening a file and closing a file and renaming files and directories. These operations are performed by name node. And slave node we also called as data node, and there are a number of slave or data nodes in Hadoop distributed file system, and these manages the data storage, and these slave nodes are the actual worker nodes. We also call them as worker nodes. Actually, these worker nodes do the tasks and serve read and write requests from the file systems clients, and they also perform block creation. Block is one unit where you store the data. So, uh, normal size of the block is around 128 megabytes normally by default. Or based upon the requirement, the administrator will create the block size. It could be 256 megabytes or something like that based upon the requirement. So in a normal regular file system, the block size is 512 bytes or 128 bytes, something like that in a regular file system. In Hadoop file system, the block size is around 128 megabytes. And deletion of the files or deletion of the data and the replication upon instruction from the name node, how many times the data should be replicated or copied, the copies of different copies of the data in different uh, nodes or different data nodes. Okay? How many times the data should be replicated? The instruction is given by the name node. Once a block is written in data node, it replicates to other data nodes and process continues until the number of replicas mentioned is created. Data nodes can be deployed on commodity hardware, cheap hardware, or inexpensive hardware. We need not deploy them on a very reliable hardware or expensive hardware. There are two processes which run for HDFS for data storage. One moment, I'll be back in a second. Hi. Name node and data node. There are two processes running on this name node and data nodes. We call them as daemons. Daemons are nothing but processes. And this is the daemon that runs on all the master nodes or name nodes. Name node stores metadata. It stores some data. We call it as metadata. Metadata is referred to data about data. Metadata like file name, and also so the number of blocks the file consumes and number of replicas, how many copies of file are there, and a location of blocks where the block is located on the name node and block IDs, etc. So name node, this metadata is available in memory in the master for faster retrieval of the data. In the local disk, a copy of metadata is also available for persistence. So name node memory should be high as per the requirement. The name node memory should be very high because it stores all this information. And data node, this daemon runs on the slave node or data node. These are actual worker nodes that store the data. Okay, and this is a brief introduction about what you call HDFS file system. So the commands are like similar to Linux. So Linux commands such as in order to list the files and directories you have ls. So cat is to read a file content. Copy cp is the command for copying the one file to one from one source one place to other place. etc. These are the commands available on Hadoop as well. So you should be familiar with the Linux commands, basic commands. Then it is very easy to operate on Hadoop. So how you can manage the files on Hadoop file system. And Yarn is also another component of Hadoop, and we'll see the introduction, architecture, and Yarn nodes and daemons, resource manager and node manager. Okay, and Yarn refers to it is the expansion of Yarn is yet another resource negotiator. It is the resource management layer of Hadoop. So, what are the resources available? We have name node and data node, and we have to manage these resources. So, we require a, a tool. So, we call it as Yarn, and it has been introduced in Hadoop 2.x. Now, the Hadoop is 3.x. The version of Hadoop is 3.0. Yarn allows different data processing engines like graphical processing, interactive processing, and stream processing, as well as batch processing to run and process data that is being stored on HDFS system, Hadoop distributed file system. Apart from resource management, Yarn can also does job scheduling. So at a given point of time, you want to run an application, you can schedule it using Yarn. So it also manages the resources as well as job scheduling. So it also extends the power of Hadoop to the other evolving technologies, so they can take the advantage of HDFS. HDFS is the most reliable and popular storage system on the planet. And MapReduce. So this is a brief introduction about Yarn. We'll see what is Yarn and how you can manage all those things when you enroll in the class. So MapReduce is a technique. So a task is subdivided into subtasks that we call as mappers. All these subtasks have been processed parallelly and they generate the output. All these outputs from subtasks are aggregated or summation is done, and then we call it as reducer. So map reduce, there are two terms, mappers and reducers. In the mappers, the task is divided into subtasks, and all these subtasks are executed parallelly. And once they get the output, they are aggregated and in the reducer. So it is a core component of Hadoop, and it processes huge volume of data in parallel by dividing the work into a set of independent tasks. Each subtask is independent of other tasks. So in MapReduce, data flow in step by step from mappers to reducer. There are two components in MapReduce. One is mapper, another is reducer. In mapper, the tasks are tasks are divided into subtasks, and each subtask executes parallelly and generates some output. In reducer, these outputs that are generated by the subtasks are aggregated, and then finally the output is given in reducer. Okay. So you have any questions here? We will be learning various phases of MapReduce job execution, such as input files, input formats in Hadoop, input splits, record reader, mapper, combiner. These are all the terms we use. These are the steps we use in the MapReduce job execution. Shuffling and sorting, reducer, record writer, and output format in detail. Okay. So now I will define what is MapReduce and we'll go to the next. MapReduce is the data processing layer of Hadoop, and it is a software framework for easily writing applications, and which process these applications process the vast amount of structured and unstructured data that is stored in Hadoop distributed file system. Okay. How Hadoop MapReduce works. In Hadoop, MapReduce works by breaking the data processing into two phases, map phase and reduce phase. In map phase, the task is being divided into subtasks and they are executed parallelly like that. Okay. It is a map is the first phase of processing where we specify all the complex logic, business rules, and costly code in the mapper section. And then reduce is the second phase of processing where we specify lightweight processing like aggregation and summation. So I'll skip these things. So these are all the various steps. Then we have PigLatin. So if you're not good at Java, so MapReduce programs have designed using Java only. So if you're not good at Java, then PigLatin is the tool to design the applications with ease. It is an abstraction over MapReduce. Pig is an abstraction over MapReduce. PigLatin is a language. It is a tool or platform which is used to analyze large sets of data, representing them as data flows. Pig is generally used with Hadoop, and we can perform all the data manipulation operations in Hadoop using Pig. What are the data manipulation operations normally we do? We insert the data, and when we modify the existing data, we call it as updating, and we delete the data that is no longer required, and we retrieve the data from the existing data storage. So these are all data manipulative operations. Okay. If you are familiar with SQL, you will be familiar with data manipulation operations. Basically, the data manipulative operations are insert. You first insert the data, then you update or modify the existing data, and then delete the data that is no longer required. And you select or you retrieve the data that is required. Okay. So these are the data manipulative operations, whether you do it on a file or you do it on a database table, etc. These are the data manipulative operations. So to write data analysis programs, Pig provides a high-level language that is known as PigLatin. So this language provides various operations using which programmers can develop their own functions such as reading, writing, and processing data, reading the data and writing the data into files and processing the data that is stored in files. So this is one example of PigLatin I will show you, and then I will stop here. So we have a data file like this, population. It is stored in the form of a file. It is comma separated value. It is stored in the form of comma separated value. It doesn't have any heading actually here. Look at this. 1850, some numbers are there. So the first column representing the year, second column represents the range of age, and third column representing, we have only one and two. One represents male, two represents female. So the gender is represented in the third column, and population count is represented in the fourth column, but we do not have column headings. So this is the data stored in a file we call it as comma separated value file. So you can open this file using a notepad or any other application or Excel sheet. So this is data. We have the data is there, and you want to process the data. What is, say for example, what is age group 50, for example, age group 50 in all the years, you want to extract the data, say for females. So we can write a program such as like this. So this population.csv, this is the file actually. You load into a variable called population. So this is a PigLatin program. It looks like this. And you say using pig storage and the data is separated by comma. Also, you can define the fields. Load the population.csv using pig storage and the data is separated by comma. As first column is year and the data type is integer, all the numbers. Age, the second column is age, representing age. And also the data type is integer. And similarly, the third column is representing gender and the data type is integer. And fourth column is population size or population count and that is also integer. Now I want to filter the data. I want to extract the data by age group 50 and gender is equal to 2. 2 represents female. So I want to find out the population count for each year whose age is equal to 50 and gender is equal to 2, which is nothing but female. So there is a variable called pop55 female. This is the variable and filter is the command. I'm filtering the data. Filter population. Population consists of the data. So population.csv consisting of the data and it is stored in this variable population. And by age is equal to 50 and gender is equal to 2. And you get all the data and you dump this data on the monitor. Okay. So unfortunately, I have a cloud environment where I can execute the programs, but somehow it is not working today. So this is an example of PigLatin program. Okay. You execute this file and you will get the results. Okay. I'll stop here for today. And if you have any questions, just let me know. No questions? Okay. All right. Ashana, I will stop. I will conclude here for today's discussion. And all right. Thank you. Have a great one. Have a great day. Bye bye.